This is a question from one of the Facebook groups. This one is from a Singaporean maths group. And it's quite an interesting question because I teach a lot of international students from Singapore, America, the Middle East, and various other countries. And this question, it asks, consider the simultaneous equations of variables x and y, where px plus y equals 6, 9x minus 3y equals q, where p and q are constants. Determine the conditions that p and q must satisfy if the simultaneous equations have no solution. Now, typically, when we have simultaneous equations, when we first encounter them, we kind of like have to solve them algebraically, and we get some answer for x and y, and you get a pat on the back if you get it right. And then move on graphically to kind of show what's happening with the graphs. And really, sometimes we don't really understand what's going on with them. We're just kind of given a problem to solve. So we're going to solve this graphically because it has slightly more meaning to it. And we're just going to try and keep it quite simple by showing you graphically what's happening. And hopefully it makes more sense as well. But before we do this question, I need you to understand just a few basic things regarding simultaneous equations. And it's going to seem trivial at first, but just bear with me. So here we've got a graph, and I'm just going to use two simple equations rather, where y equals to 2x plus 1 and y equals to x. And we're going to try and solve this simultaneous equations, although as basic as it is, graphically and then algebraically. So graphically, y equals x, well, that's really just a straight line graph, or well, these are both straight line graphs, but it'll be something like this. Let me just adjust the angle a little bit, just so it's slightly more precise. Otherwise, the values will come a bit funny. So that's my y equals x. So that's y equals x. And let's choose a slightly different color for the graph. So y equals 2x plus 1. Well, it's going to cut the axis at 1, and then it'll be the gradients come like that. So let's change it to a straight line. So it'll be there, there, and there. So let's draw a line joining up here. This needs to be a gradient of 2. So it's roughly like that. Close enough, I suppose. And then our solution is going to be, well, where the two axes cross, and nothing too fancy there. So it crosses at the point of -1, -1. So we're going to expect our solutions to be that. And let's check it algebraically. Well, when the two intersect, or when we're solving these simultaneous equations, I can actually just write it as 2x plus 1 equals x. So when do the two kind of equal each other? And then, well, lo and behold, well, x does equal to -1, and we substitute back in, well, y equals -1 again. So this solution kind of fits. So that's when there is a solution. When is there no solution? When do these two lines never meet? Well, they never meet under one specific condition. That's when they're both parallel to each other. So if I took this line and made it parallel to the other line, like this, they will never, ever meet, which is quite sad. Because I always remember it as kind of like if you met somebody who thinks in the same line of thought, same direction in every way as you, but they will never meet. So that's why I always think it's quite sad. Kind of like lost souls or kindred spirits. So they're parallel and they'll never meet. So let's go back to our initial problem, where we've got these two linear equations. When will they ever meet? Well, it's when their gradients are exactly the same, because then they'll be guaranteed to be parallel. So let's write these equations down. So p of x, px no rather, plus y equals to 6. And then the other equation is 9x minus 3y equals to q. And then, well, let's do some rearranging. Y equals 6x, sorry, not 6x, 6 minus px. And then if I write it in a y equals mx plus c format, it's just easier for comparison. So y equals minus px plus 6. And on this side, well, I can do, well, 9x minus q equals 3y. And then I'm just going to rearrange everything 3y equals 9x minus q. And if I divide that by 3, well, I get y equals 3x minus 1/3 q. Sorry, that's a really horrible looking q. Now I've written them both as y equals mx plus c format. And well, I'll just write it like this. So y equals mx plus c. And I'm just going to put these equations down below just so that it's easy to compare. So when I put these equations down below here, well, what are the gradients? Well, the gradients, well, this is the m. So this is the gradient for here, and this is the gradient for here. And when are they going to be equal to each other? Well, it's when minus p equals to the 3, or p equals to minus 3. So the gradients, if the gradients of the second equation, y3x minus 1/3 q, is 3, which means that if p equals minus 3, this is going to have a gradient of 3 as well. So guaranteed to be parallel. But in the question, it says we've got to find p and q. So what's about the q that's going to play a factor into this? Well, let's look back into our graph again. Now, although these lines are parallel and they never meet, there's actually one case where they will meet. And when is that? Well, that's when the c part are equal to each other. And then they actually become the same line. So they actually meet at every single point because they're the same line. So not only do we need need lines to be parallel, but we also need the c component, the constant, not to be equal. So the gradient has to be equal to guarantee they're parallel, but the constant cannot be equal to guarantee that they're not the same line. So let's go back. So the c part, well, is here, here, and here. So the c part cannot be equal to each other. So minus 1/3 q cannot equal to 6, which means that minus q cannot equal to 18, and q cannot be equal to minus 18. So under two very specific conditions, where p is equal to minus 3, so that to ensure the line is parallel, and q cannot be equal to minus 18 to ensure that they're not the same line. Under these two conditions, this set of simultaneous equations have no solution. So when p equals to minus 3 and q cannot equal to minus 18, these two equations will never have a solution. Quite an interesting question. Yeah, quite fun.